In nuclear physics, we use other units in addition to kilograms and joules. That's because, for example, if you consider the proton, its mass is 1.67, etc., 10 to the minus 27 kilograms. That's a very tiny number. However, instead, we use what we call atomic mass unit, this U, 1U. A 1U is 1.6605 10 to the minus 27 kilograms. It is actually 1/12 of the mass of a neutral carbon-12. Carbon-12 is a stable element, so 1/12 of that is what we call the atomic mass unit. A proton is almost one atomic mass unit. It's 1.007276. A neutron is about that same mass as well, but it is slightly different. Notice the difference. An electron, however, remember the mass of an electron in kilograms is 9.1 10 to the minus 31 kilograms. It is actually about 1,000 times, about 2,000 times smaller than a proton or neutrons. So it's actually 0.00030 atomic units. It's very tiny compared to that. But then the other important unit that we are going to use is going to rely on energy. And quite often we are going to use the fact that mass is some type of potential energy. We rely then on Einstein's famous equation E is equal mc squared. Remember, c is actually the speed of light in vacuum. That's 3 × 10⁸ meters per second. So in this case, if I would like to find the energy equivalent of a mass of a proton mass, I just multiply this value, which is 1.67262 10 to the minus 27 kilograms, by 3 × 10⁸ meters per second squared. So I'll get there the energy equivalent of the mass of proton in joules. An alternative, a more convenient way for finding the energy equivalent that we use in nuclear physics is using what we call the MeV, mega electron volt unit for energy. Now the conversion factor between mega electron volts and atomic mass unit is given here. One atomic mass unit is 931.5 MeV per c squared. Notice here in the table it's supposed to say per c squared. So for example here, my mass is 938.27 MeV per c squared. So that's a different unit, more kind of energy related than just writing it as a U. To find the amount of energy then, all what I have to do is multiply it by c squared. By multiplying it by c squared, I'll just cancel the c squared, I get the same number. So a proton, the energy equivalent of a proton mass is 938.27 MeVs, mega electron volts. For a neutron is 939.57 MeVs. For an electron is 0.511 MeVs.